The Bildungshausen, the engineering department at Nagasaki University, is also home to a remarkable new supercomputer that makes complex calculations in astrophysics at record speeds. Tsuyoshi Hamada led the development team. The supercomputer only cost about $420,000 to make. What's more, it's made of parts you could find in many computer stores. So first off, would you tell me how we should see and understand supercomputers right now?
Until recently, supercomputers were extremely expensive. Only a few researchers had access to them, and only a small number of privileged people had access to the technology. But now, we can build these machines with parts from PCs and workstations that are commonplace. Here, we make calculations at the same speed or faster than existing supercomputers.
The total cost of a supercomputer now being developed in Japan is said to cost about $1.3 billion. It is made up of the only most cutting-edge hardware. It's powerful and it's so versatile it can be used for many different tasks like predicting earthquakes and making better cars. By contrast, Hamada and his team developed a relatively low-cost supercomputer that makes ingenious use of commercially available parts. This part is called a GPU, a graphics processing unit. GPUs are used widely in computer and video game displays. By forming a cluster of 760 GPUs to make calculations in astrophysics and hydrodynamics, the team broke the record for computing speed with 158 trillion calculations per second. This program estimates the expansion of the universe following the Big Bang. Professor Hamada can run simulations that make complex calculations about the origin of the universe and the movement of the galaxies. The team recently won the Golden Bell Prize in the category of Prize per Performance. The award is one of the most prestigious in the supercomputing field. Tell me more about the development of your computers. What's the hardest part of it? And what is the key to your success?
There are processors in every computer, and there are tens of thousands of them in this computer room. Theoretically, a computer's performance reflects the number of processors that are connected to each other. But you still need a program that coordinates the processors smoothly. The goal is to understand the program's constraints, so it can give commands to the processors in the most efficient way possible. The important thing, then, is not just building a computer, but understanding what research it will be used for. Here, we are doing physics calculations, so the extent of our knowledge of physics really makes a difference in this case.
How would this invention be beneficial to our daily lives in the future?
If knowledgeable people from different fields keep building computers like we did and using them in creative ways, it's going to result in a great deal of innovation. In order for low-cost supercomputers like this to be used all over the world, people from other disciplines must share their knowledge on how to use this kind of computer effectively. Because we've lowered the cost significantly, it may lead to more people using computers like this. They might create new businesses that had never been imagined before, or who knows, even develop new branches of science. What I hope for most is that the biggest applications haven't even been imagined yet.
Professor Hamada's supercomputer is creating a buzz among international researchers and businesses. Although computers have limitations, researchers who take advantage of low costs could one day make individualized supercomputers that meet the needs of specialized fields. Hirofumi Nakano, NHK World.